Welcome to Basic Physics Application in the mode for Startup Presentation. This application contains 15 main chapters which covers the basic knowledge about physics for grade 10 to 12. This application focuses on the understanding by describing with images and narration, which makes the difference with the classroom learning. As there are lots of content, then we divide the knowledge into 4 parts with 4 chapters each. Anyway, in this presentation mode, we will present only the chapter 2 of part 1 as a sample. In this chapter 2, Forces and Newton's laws, it contains 6 topics which explain the main 3 laws of Newton, including source, meaning, and implementation. For the person who has no previous knowledge about physics, please select topic 1, 2, and 3, respectively, for better understanding step by step. Before we start Newton's first law, let's go back to the time before Newton sat under the apple tree and created the equation of sigma F equals ma. About 300 BC, Aristotle, the Greek philosopher, described the knowledge about the object that a force is required to maintain motion, even at a constant velocity. The velocity of the object is proportional to the strength of the applied force. In the next 1,800 years, Galileo Galilei built on the idea about the concept of the object that an object in a state of motion possesses an inertia that causes it to remain in that state of motion unless an external force acts on it. Unfortunately, Galileo died in 1564, which was the same year that the other great scientist was born, Sir Isaac Newton. Later on, Newton adopted the concept of Galileo and renewed as his first law. In order to honor Galileo, he named this law as law of inertia, which stated that in an internal reference frame, an object either remains at rest or continues to move at a constant velocity, unless acted upon by a force. If you would like to know more about law of inertia, please select. If you would like to know about the background of Sir Isaac Newton, please select. For the Newton's first law, let's imagine that the rock as an object in the space without any force. The rock will stay still as it is for 100 years or even a billion years if there's nothing bump into it. The collision can be called as force. In the other case, if the rock is moving at a speed of a on the direction b, it will maintain this velocity and the original direction for 100 years or 1,000 years until something bumps into it. In this case, it could be called transmission of force. And, of course, if the force is 0, then there is nothing affecting the rock at all. Please keep in mind to imagine the rock in space because if there is on Earth, there will be gravity involved. In both cases mentioned earlier, it can be concluded that for case 1, if the object is stay at rest, or for case 2, if the velocity of the object is constant, then there is no acceleration or the velocity is equal to 0. It can be stated mathematically as sigma F equals 0. the example of using equation sigma f equals 0 to solve the physics problems.